Welcome to ePathshala PG courses on computer science. This course is about web technology, and now we are going to see about the next module which describes about the XPath. The objective of this module is to tell you about the introduction of XPath, and we will see how to write the XPath expressions, and we will see what are the operators and functions that are supported in XPath. So, now let us see about the introduction to XPath. So, XPath is an XML path language which is used for finding information in an XML document. And we know that this XPath is a major element in the XSLT standard. So, without this XPath knowledge, we will not be able to create an XSLT document. XSLT is an XML style sheet transformation, or this is the concept or technique XML technology used for creating an XML style sheet. So, when you want to navigate the XML file or identify the information within an XML file, we need to use this XPath, using which we will write an XSLT file. So, XPath uses the path expressions to select nodes or node sets in an XML document. These path expressions look very similar like the expressions we use in JavaScript, Java, XML schema, PHP, Python, C, C++ or any other languages. So, now XPath is a syntax for defining parts of an XML document. So, this XPath uses path expressions to navigate in an XML document, and it contains a library of standard functions and operators, and XPath is a major element in XSLT. We can see in the diagram this XPath works with XSLT, XQuery, XPointer and XLink. So, it is widely used, XPath is widely used in XQuery, XPointer and XLink, and it is also a major element in XSLT. So, let us see that how this XPath writes or forms the query string. First of all, this XPath identifies 7 kinds of nodes in an XML document. The nodes are categorized as element node, attribute node, text node, namespaces, processing instruction, comment and document nodes. And XML documents are treated as tree of nodes, as we have seen in the previous modules. This is an XML code taken for reference in the coming slides to form a query expression. So, let us take an XML code which describes about the bookstore. So, bookstore is the root element node as specified. Within this bookstore, we have n number of book elements. So, now in this example, we have specified one book element. This book element has got the other elements called title element, author element, year and price. Now, we can see what about language. This is an attribute node, attribute of the title element node. So, this is an attribute node, and author is one of the element node which is given under this book element. So, when you want to navigate this XML document, we start from the root node bookstore. Under this bookstore, we have a book element, and under this book element, we have 4 other elements called title, author, year and price. Now, how is the structural relationship is maintained between the nodes is given here. So, we say that any node has a parent node for an element or an attribute, and we know that each element and attribute has only one parent, and in the only one direct parent. In the above example, we have seen the book element is the parent of the title, author, year and price. the children node or the element nodes that may have 0, 1 or more children. So, now we can see the title, author, year, price elements are all children of the book element. And sibling node are the nodes that have the same parent. So, title, book, author, price elements are all siblings to one another. So, this is how in an XML document the structural relationship between the elements or between the nodes are maintained, and the same structural relationship is also used by the XPath technology. Now, there is a node called ancestor node. When do you call a node as an ancestor node? Any node's parent or parent's parent are called as ancestor nodes. So, the ancestors of the title element or the book element and the bookstore element. Descendant nodes are the node's children or children's children are called as the descendant nodes. So, in the above example, the descendants of the bookstore element or the book or title, author, year and price element. The descendants of the book element are title, author, year and price element. So, all the children and the children's children are called as descendant nodes. So, now we can see the syntax how to write an XPath query. For selecting nodes, we simply give the node name, which selects all nodes with the name given as the node name or the test node name. Now, if you use a slash, the forward slash, it selects from the root node. If we use a double slash, this selects node in the document from the current node that match the selection no matter where they are. So, when you specify a double slash, it selects all the nodes wherever it is available in the node that comes under this specified node. And a single dot selects the current node, a double dot selects the parent of the current node, and an @ symbol selects the attribute. And now we can see XPath uses a path expression to select node or list of nodes from an XML document. So, now this is an example given. When you specify the name of the element, it selects all nodes given with the name called bookstore. In the given example, we have only one element with the name bookstore. So, given the name of a node, it selects all nodes with the specified name. And a slash bookstore selects the root element bookstore. So, if the path starts with a slash, it always represents an absolute path to an element. Now, this bookstore slash book selects all book elements that are children of the bookstore. So, we can now understand bookstore slash book. So, this is a path given. It selects all book elements that are children of the bookstore. Now, a double slash book. This selects all book elements no matter where they are present in the document. Now, bookstore double slash book selects all book elements wherever they are in the document, but they should come under this bookstore element. So, it selects all book elements that are descendant of the bookstore element no matter where they are, but they should be under this bookstore element. A double slash @ lang selects all attributes that are named as lang. Now, this XPath syntax used with can also be used with predicates. Predicates refers to XPath expression written in square brackets, and predicates are used to find a specific node or a node that contains that specified value. Now, the path expression is given as slash bookstore slash book. The predicate is specified within the square bracket. So, this selects the we look for the books that are under this bookstore element. So, when the predicate is given as 1, it selects the first book that is the child of the bookstore element. The next example we can see all the books that are under the bookstore element, but the predicate given as last. So, this selects the last book element that is the child of the bookstore element. The next example we can see bookstore /book, the last but the one. So, we use a method called, we use a function, this is a function, XPath function, and XPath function -1, this is given as the predicate value. So, it selects the last book element, but before the last but one before the last element, book element. The next example we can see, it selects the book and the predicate given as position less than 3. So, it selects the first 2 books under the bookstore element. So, now we will see that how the path expression and predicates are used with examples. Now, here we can see that we select all the title elements, but the predicate given as the attribute should be an lang attribute. So, all the title elements that have an attribute lang would be selected for this path expression. The next path expression is given as all the title elements, but the language attribute should have a value called en. And this is an example, gives path about the path expression that selects all the book elements under the bookstore, but the price should be greater than 35. So, it selects all the book elements of the bookstore element that have a price more than 35. Now, we can see this is a path expression which tries to select the titles of all books under the bookstore element, but the price should be greater than 35. So, the path is given, it starts from the bookstore, it goes to the book, the price of the book should be greater than 35, if so it selects the title. So, it selects all the title elements of the book element of the bookstore element that have a price more than 35. Now, how do we select unknown nodes? So, we have a support for wildcards in XPath. So, this is to select unknown XML nodes. So, we can see here the wildcards that are used are an asterisk which matches with any element node, and at asterisk this matches with any attribute node. At symbol represent an attribute in an XML file. So, this attribute can be anything that matches with any attribute node, and a node function symbol matches any node of any kind. Now, how do we select several paths using this XPath expression? By using this pipe operator, pipe or symbol in an XPath expression, you can select several paths. So, here there are some examples given for the path expressions that uses a pipe symbol. Here you can see that it selects either of the two paths. One is that it retrieves all the title elements that comes under the book element, or it retrieves all the price elements that comes with the all book elements. So, it selects all title and price elements of all book elements. The next path expression specifies all title and price elements in the document. So, a double slash specifies the elements that are present anywhere in the document. Now, the next example we can see it selects all title elements that comes under the bookstore under the book element and all the price elements anywhere in the document. Now, axes are also supported, XPath axes are supported in XPath expressions. Axes are named after they refers to the axis on which elements are lying relative to an element. So, the relative path expressions can be given using XPath axes. So, we use the axis name like ancestor, which selects all ancestors. Ancestors means it can be a parent, grandparent, etc. of the current node. Ancestor or self axis name represent to select all ancestors of the current node and the current node itself. Attribute selects all attributes of the current node. Child selects all children of the current node. Descendant selects all descendants of the current node. Descendant means the children or grandchildren. Descendant or self selects all descendants of the current node and the current node itself. and following selects everything in the document after the closing tag of the current node. So, this access can be made relatively forward or relatively backward. So, either following is a relative access going forward, and ancestor or self is an access going in the backward. So, we can specify a relative path expression either in the forward direction or in the backward direction. And now there are other access name like following sibling. This selects all siblings after the current node, it does not include the current node. Namespace selects all namespace nodes of the current node. Parent selects the parent of the current node. Preceding selects all nodes that appear before the current node except the ancestors attribute nodes and the namespace nodes. Preceding sibling selects all siblings before the current node, and self selects the current node. So, these are the access name we use in order to give an relative path expression. So, in XPath we use an absolute path expression or a relative path expression. So, a location path can be absolute or relative with XPath expression. Normally an absolute path starts with a slash and a relative path does not. In both cases the location path consists of one or more steps each separated by a slash, and each step is evaluated against the nodes in the current node set. Now we will see that this location path expression consists of all the things what we have seen earlier. This location path expression can contain an axis which defines the tree relationship relative to the selected nodes or the current nodes. A node set which identifies a node within an axis or specifies the name of the node to be selected. 0 or more predicates to further refine the selected node list. So, now you can see the syntax for a location step is you give the axis name, then the scope resolution operator, the node of test along with the predicate. Now, these are some examples which returns either a node set, a string or a boolean or a number. Now, this is an example. Child, the access name is the child and this is the node of test. You can see that it selects all book nodes that are children of the current node. This is an example which selects the language attribute of the current node, and this selects all element children of the current node. This is a wildcard. So, it selects all element children, all the children of the current node, and this selects all attributes of the current node, and this selects all text node children of the current node. So, the relative access is given as child, attribute and so on. Now, you can see here this is an example which selects all children of the current node. This selects all descendants, but it is a book descendants of the current node. This selects all book ancestors of the current node. This select all book ancestors of the current node and the current node also or self, and this selects all price grandchildren of the current node. So, this you can see here child, all this is all grandchildren and the price grandchildren of the current node. And operators are also used with XPath. You can see that these are the operators you can find with XPath expression. This computes two node sets. We have seen that it can make multiple paths at the same time. So, using a pipe symbol, pipe operator. So, this selects all book nodes and all CD nodes, and an addition which normally comes with the predicate. These operator comes with the predicates, and you can use a less than. We have seen that price should be more than 35. So, there and all we have understood that these are some of the operators that comes along with the path expressions. So, we can see price used along with these relational operators, and we also have these boolean operators. So, when you want to compare two conditions, more than two condition, these logical operators like OR, and mod, everything used with the XPath expressions. Now, this XPath is actually a query string which is for retrieving information from an XML document. So, expressions are normally, this XPath expressions are classified as sequence expressions, range expressions, filter expressions, arithmetic expressions, comparison, logical expression, for expression, conditional expressions and quantified expressions. And here is where we can see that some of the XPath functions that are also available as a library for XPath language. So, some of the functions are like node set functions, string functions, Boolean functions and number functions are available in XPath. So, now to work with node sets, either with the implicit current node set or one passed as a parameter, we use different node functions. We will see in the coming slide. The string functions for working with strings, and to work with booleans we have boolean functions, to work with numbers we have number functions. So, these are the predefined functions defined in the core library of XPath. Now, this is an example of how XPath function is used. So, here you can see that to determine the number of articles, we can use a method call, use a function called count. So, here you can see that it determines the number of articles that is returned by the person called Jones. So, it selects all the articles from the journal, that is the articles that comes under this journal element, but the name of the author should be Jones. To find all authors whose last name begins with MC, we use a string function called starts with. So, it selects all authors or it finds all articles whose author's last name starts with or begins with MC. Now, these are the defined XPath node function. Some of them have been specified here. So, we have a function called last. So, this in the earlier slides we have seen the function called last. This returns the index of the last item of the current node set. So, we can see an example here, journal article last, which means that it returns the last article, and the number of the returns the index of the last article. And here you can see that we use a function called position. This returns the index of the current item in the current node set. So, you can see here the article's position, if it is less than 3, it gives the article. Then we use a function called count. This returns the number of items in the current node set. We have seen in the previous slide an example for count. So, this counts the number of articles that comes under this journal. And then there is a method called function called node set ID, which returns the elements with the ID specified. An example is given here. The ID of the ID is specified as article 1 and the author and the last author on the node list. Now, some of the string functions have been given in the slide. We have a string method, string function, which converts an object, possibly the current context node, to its string value. So, here you can see that in the example, the author, it is converted, and then there is a next method called concat. This is for concatenating 2 or more strings. So, here you can see that the strings given. So, an example of concatenating the 3 strings, salutation, this is an empty string and the last author element. And then we can use a function called starts with. This determines if the first argument starts with the second argument string. So, here it checks whether the title starts with advanced. And now this is an example which determines if the first argument ends with the second argument string. So, it checks whether it ends with the title elements ends with advanced. And some more string functions are given here. So, contains is a string function which determines if the first argument contains the second argument string. So, if the title contains the second argument as XPath, and there are few functions, the few overloaded functions substring, and these are separate substring functions which retrieves the substring of the first argument that occurs before the first occurrence of the second argument string. So, we can see here the substring before this slash would be printed. So, the substring before the second argument string in the first argument would be returned. Now, the substring after the thing that is set, that is given in the second argument would be returned by a method called substring after. So, this retrieves the substring of the first argument that occurs after the first occurrence of the second argument string. So, it returns all the substring that comes after this second argument is given as a slash. So, the strings that comes after the slash should be returned by this function, and these are a substring function. So, substring retrieves the substring of the first argument starting with the index of the second. So, in the first argument is given as Jones. So, starting with the index 3, the rest of the string till the end of the string would be returned by this method, and string length determines the length of the string or the current context node coerced to a string. And there is a method called normalize space, retrieves the string with all space normalized. And some of the Boolean functions are specified here, listed here. This Boolean converts the argument to a Boolean value, like an object specified in the string function to convert to a string. We have a Boolean function that converts the argument to a Boolean value. And then there is a function called not. This negates the Boolean value, and there is a function called Boolean from string which returns true if the required parameter string is true, 1 or yes. In all other condition a false would be returned. And here Boolean true, the Boolean value is true, it checks the Boolean value is false, and if it evaluates the first parameter as a Boolean, returning the second when true, otherwise the third. So, here it checks if the first, it checks if a match is found, if it is true it returns the second argument as match found, else it returns the third argument no match. So, this if takes 3 parameters, the first one is a Boolean, checks if yes it returns the second, if no it returns the third argument. And these are the number functions supported in XPath. So, number is a method which converts the argument or the current node to a number value. As earlier we have seen, all the other functions in all other data types you have the same functions. So, here you can see it is converting the argument to a number value, and then this sums the node set value, the sum function. Floor returns the largest integer that is not greater than the number argument, and round returns the number argument after rounding it, sealing it. Now, we have seen that we have explained about this XPath, how to define the XPath expression and to navigate in XML documents. So far we have seen how we have explored about the XPath syntax, how to specify the location path expressions. It can be absolute or relative path expressions. We have seen how the expressions can be given along with predicates, how it can be used for specifying unknown nodes using wildcards, and we have seen about how to set relative path using XPath AXES, and then we have also seen the other XPath operators that are used with expressions and the XPath functions. So, the XPath functions that are available with for string handling, number handling, Boolean handling and for node set handling. Thank you.